Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002, and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we are going to talk about SQL. We had already covered the fundamentals of SQL in the last lecture. So, in this lecture, we are going to look at more operations of SQL. So, the objectives of this lecture is to explain the set operators supported by SQL, to explain the use of comparison operations, and to understand aggregation and grouping, which are very important as far as database applications are concerned. So, let us first look at set operations. Now, the set operations are similar to what set operations we have already seen in relational algebra, but we are going to look at how it is defined exactly in SQL. We have also seen set operations in fundamentally in maths also, similar meaning, but we are going to see some more operations which are interesting. So, the set operations are union, intersect and except and they operate on relations according to the relational algebra operations, union, intersection, as it is seen here, these operators. Now, each of the above operations automatically will also eliminate duplicates. To retain all duplicates, you have to specifically mention it as union all, intersect all and except all. Except is actually the which we have already seen actually before, it is equivalent to the difference operation or the minus operation. So, suppose a tuple occurs m times in the relation R and n times in the relation S, then it occurs as m plus n times in R union all S, and minimum of n comma n times in R intersect all S. This is to explain to you the meaning of union all. We are not trying to eliminate duplicates. Maximum 0 m minus n times R except all, when you are using the except all operations of R except all S. So, now let us look at union, intersection and difference or except for the tables or the relations as it is so called. So, the union of A and B, as in normal set theory, stands for A union B and can be given by this diagram. So, A union B is this A union B. As I already told you, if you just write union, the duplicates here will be removed. If you do not, it will be given as it is. So, a table containing all rows from A as well as B, that is the meaning of A union B. Now, the intersection similarly of A and B is nothing but A intersection B, and it is given as only this part. This is A intersection B, this is a normal set theory, and it is a table. The result will be a table which contain only rows that appear both in A and B. Again, there is a question of whether to eliminate the duplicates or not. So, if you write as intersection all, it will not eliminate the duplicates. Then the difference, again we can say the difference is, this is A minus B, A minus all the tuples that are there in B. So, it is a table containing the rows or the tuples of A that appear in A, but should not appear in B, that is the meaning of difference. So, this is the set base view of that. Now, let us take an example. Let us assume that you have a bridge club and a chess club. Let us assume that you have a bridge club and a chess club, and we want to consider the members of the bridge club and the chess club. The two database files, both bridge club and chess club, they have the same structure. You have an ID, a name, a sex and a class. So, let us assume this is the bridge club which we call as A, and this is the chess club which we call as B. Now, if you, before using SQL in any of this, you will have to open the two tables first. So, select A, use bridge, select B, use chess. This initiates A to the bridge relation and or table and B to the chess relation or table. Then select from where union, select from where union. So, this is the format of the operation. So, the two clubs want to hold a joint party. So, I want to make a list of all the candidates. So, we want a union operation. So, this is select star from bridge union, select, this is the format, select star from chess. So, select all the tuples from bridge and all the tuples from chess, union it and order it by, we will see this later, class, name into table party. So, we are forming a new table called party which will be the union of the members tuples in bridge and chess. So, the same way you can have select something from table 1 where column in select, you do not have to have a star completely. So, here print a list of students who are members of both clubs. So, we are looking at an intersection. So, this is the intersection operation. So, select star from bridge, you select all the members from bridge and who are members of both clubs. So, print a list of students. So, here you are using the intersection operator where we are selecting the ID from the class and you are printing it. Now, let us look at the next operation, not in. So, make this is the equivalent to the except operation or the difference operation. Make a list of students who are members of bridge club, but you do not want them to be members of chess club. So, that is the difference. So, select star from bridge where ID that is because it is a primary key, not in select ID from chess into table difference. So, that is how you are going to implement it using SQL. So, we look at some other operations also. So, some of the operations are find all customers who have a loan, an account or both. So, select customer name from depositor, assuming a depositor information, union select customer name from borrower. So, from depositor or borrower or both you will get the tuples. Another one, find all customers who have both. This is an intersection operation. This is basically to tell you where you should use the union operation, where you should use the intersection operation. So, select customer name from depositors, intersect with this. Find all customers who have an account but no loan. This is equivalent to a difference operation. So, except this. So, these are the simple way of telling the three operations. Union where you want either the tuples from both depositor and borrower, that is union. Here you want both, that is the tuple should be present in both depositor and borrower, then only you want to output it. So, that is called intersect. And here you want people who have an account, but who do not have a loan. So, that is this is the difference, or it is told as except. So, let us take another example, just again to explain that. Let us take another example. Find sailors who have reserved a red and a green boat. Okay, so, now we are talking about two relations, boats and reserves, and we are talking about people who have reserved both a red and a green boat. Now, what we want to first do is, in this boats relation, we want to find red and green only we are bothered about. So, you can forget about this tuple, that does not take part in the relation, and we want to find people who have booked both red and green. So, that is what we are trying to do. So, this is about the sailor IDs. So, now you have the sailor IDs. Now, in the sailor IDs, now here we know that 101 boat is red, 103 is red, 105 is green. So, we want a result where a sailor has booked 101 or 103 and has also booked 105. So, now look at this is a sailor, he has booked 101, so he has booked a red boat, he has booked a 105, so he has booked a green boat. So, the answer that we need is 1. So, the only sailor who has booked both, reserved both a red and a green boat is only 1. Okay. So, that is the answer, intersection answer. So, this is the red and green, these are the red and greens, and we get. Now, find sailors who have reserved a red and a green boat. Now, let us look at how this is said. So, I select R dot SID, R stands for, and before that I am defining B and R, B stands for boats and reserves stands for R. So, I want to select the SIDs of people from the reserves relation. Now, but what I am doing is I am saying that the boat color has to be red. Okay. So, he has to have reserved a red boat. Now, if he has to have reserved a red boat, then the RIBD, that is in the reserved the boat ID and the boat relation boat ID should be the same. So, what happens here is I am taking some, so let us look at this. So, here I am having the boat ID and I am first saying red. So, I am having boat ID red means I will get 101 and 103, and then in the reserves relation I have 101 and 103. So, I am finding out the reserves SID, so I get 1 and 2 actually. So, in this place I will get 1 and 2. Then here what happens, green. So, here I am getting green, that is 105, then I go to the reserves relation 105, that is this boats BID, B dot BID should be equal to R dot BID. So, I get 105. So, 1 alone has reserved 105. So, 1 2 is the first relation, this is people who have reserved red boats, this is people who have reserved green boats. I want only the sailors who have reserved both boats. So, the intersection of 1, 2 and 1 gives me 1. So, that is what is told here. This is for finding out people who have reserved or the sailors who have reserved red boats. This is to find out the sailors who have received green boats, which is this gives me this 1 2, this gives me this 1, and I need the intersection of 2. So, I get the answer as 1. So, this is what we are doing in the first step. Find sets of sailors who have reserved a red and a green boat. Let us understand this better. Now, select R1.SID from boats B1 reserves R1, boats B2 reserves R2. Now, where B1.color is equal to red and B1.bid equal to R1.bid. So, this gives me the find red reserve boats. This is another way of telling the same query, nothing different. B2.color is green and similarly find reserve boats, and then I find this and this are equal, find matching green and red reserved boats. So, this gives me an intersection without actually using intersection. So, this is also equivalent. So, please note there is no one way of writing a SQL query for getting the same answer. So, if you look here, this query and this query are equivalent. Okay. Here we have used only 2 B and R, here we are used B1 R1, B2 R2. Red boats are B1, green boats are B2, and people who have reserved red boats are R1, people who have received green boats are R2, and if these two are same, then you are actually implicitly meaning an intersection. So, that is this. So, if you do this way, you get here, these are people who have reserved red boats, green boats, and then I get the intersection. So, you will get the same answer. So, that is about the operations of set operations like union, intersection and difference. Now, let us look at set comparison operations. So, tuple expression in. So, true if tuple is a member of the set. You can also define something called not in, and you can also have x's and not x's. We will come to this. So, true if set expression evaluates to a set with no duplicates, each row can appear exactly once, then you call it as unique, otherwise you call it as not unique. And you can also have this is true, this is the operator comparison operator any, true if the set expression contains at least one member that makes the comparison true, then at least any one at least you should have. So, let us look at first the x's relation, true if the set evaluates to a set which at least has one member. So, that is x's. Find all customers who have an account at all branches located in Brooklyn. So, here is this set select distinct s dot customer name from depositor as yes, where not exists select branch name from branch. So, now I am looking at all the branches in Brooklyn and I am looking at least he should have an account at all the branches. Okay. So, this is the way that this query will be written. You cannot write this using equal to all and all that. So, this is the way you have to write it. So, now find sailors who have reserved all boats. Suppose I want to do this, let x be the set of sailors and y be the set of all boats with reservations. So, select s name from sailors yes. So, I get all the sailors, find sailors such that, and where not exists select b boat. So, there is no boat that has not been reserved, that is what this means. Where not exists select, so at least that boat has been reserved by that yes. So, yes is the person who has reserved the boat, I mean yes is the set of all sailors and this is a set of all boats, and here we are trying to connect sailors who have reserved all boats. So, that is what you want to find sailors who have reserved all boats. So, without a reservation by sailors. So, here there should not exist with a boat without a reservation for sailor yes. So, this is the division operation. So, this is find sailors who have reserved all boats. So, this is the question of the boats being reserved, 2 boats are there, only 2 boats are there and only one sailor has reserved both the boats. So, the answer that we actually want is 3. Okay. So, this is the way find sailors who have reserved a red or a green boat can be written similarly. So, here one way is put an OR operation, or try to find out all the people who have reserved red boats and all the people who have reserved green boats and then remove duplicates, you will get the union of that will give you red or green boats. So, this is again the AND relation. So, you can also use a self join which we will come into later as we explain, and this is except how to use except, that is find sailors who have not reserved a boat. So, find all the sailors and here except this he should not have reserved a boat, if this gives true then except is not true. So, these are some of the string operations that we have seen, and we will go later on into more string operations. Before we do that, up to now we have looked at two things, one is the set operations and one is comparison operations. We will continue after the break. Welcome back after the break. Before the break we were just starting on how the SQL provision for string operators. Now let us look at string operations. So SQL basically includes string matching operator for comparison on character string, actual values. The operator like uses patterns that describe two special characters. So you can have any character, percentage the character matches any substring, and underscore matches any character. This is substring and this is character. This is provided in all string operations. So find the names of all customers whose street includes the substring main. This is a typical example. So select customer name from customer where customer street like percentage main. So this main says that the customer street values in the tuples should have the substring main. This is how it is explained. This like is a keyword and percentage is also a special operator given to specify the substring. So this will match with the name main percentage. So SQL supports a variety of string operations such as concatenate, converting from uppercase to lowercase or lowercase to uppercase, finding string length, extracting substrings and so on. All these operators are provided by SQL. These are important when we are doing a lot of operations. For example, when people enter data, they may enter it in lowercase or uppercase, but still should find a match. So this is a typical use of these type of string operations. It also provides string comparisons are provided. In addition to that, SQL also provides arithmetic expression. So select s dot age where s dot age minus 5 as age 1 and 2 into s dot age as age 2 from sailors where s dot s name equal to dustbin some name, and select s1 dot s name as name 1, s2 dot s name as name 2, as is the way we are defining those variables. Sailors 1 S1 and sailors 2 S2, and what we are doing is we are saying that 2 star S1 dot rating is equal to S2 dot rating minus 1. So these are type of typical, this is minus 5, this is 2 into and so on. These type of arithmetic expressions are also allowed in SQL. So now let us take some examples. Select S dot name from sailors S where S dot name like B underscore percentage B. This underscore stands for any one character and percentage stands for 0 or more arbitrary characters. So this depends on many other languages use such type of methods for indicating one character and substring, and so similarly SQL also provides this. So now let us look at an example of comparison. Expression in value 1, value 2, value 3, expression between value 1 and value 2, expression like percentage and underscore. So you can have anything. So all these are examples of comparison operation. So let us look at some interesting examples. So if you look at list the students who are born on Wednesdays or Saturdays. Okay. So select name, class, this is a date of birth as birth date from student where date of birth in, we are using the in operation, in 4, 7 we are assuming that 4 stands for Sunday, Monday, Tuesday, Wednesday. So 4 stands for Wednesday and Saturday is 7. Okay. So this is a comparison operation. So you will get the result of the name, the class and the birth date of all people, but the day. This is an operation providing the day for all people who are born on Wednesday or Saturday. So this is these are some idiosyncrasies you should know about. 4 stands for Wednesday, 7 stands for, and the operations to get these days. So actually there is an inbuilt operation which calculates this for you. List the students who are not born in January, March, June and September. This is another example. Select name, class, date of birth from student where month date of birth not in 1, 3, 6, 9 stands for January, March, June and September. So there is a special order in which these and represented by numbers, so that it is easily done. So this will give you a result of the name and the class and the date of birth of all students from the student database where the birthday comes in these 3, not in these 3 months. That is what we have said. This is the use of not in. So January you should not have, it is not there, March is not there, June is not there and September is not there. So, these are what you get as result. So, we have got a not in operation. Now, let us look at another. List the 1A students whose maths test score is between 80 and 90, including 90. Let us assume this is our query. So, what we are doing? We are saying name, M test from student, where class equal to 1A, you are restricting the class, this is a selection operation again, and you are saying that the test score, M test score must be between 80 and 90. So, this will use inclusive, that you should know whether it is inclusive, mostly it will be inclusive. So, you will get the result of these names and the M test. Only thing is these are all between 80 and 90, which is what you want. So, here you are using between and an. Now, let us look at another example. List the students whose names start with T. So, obviously, you will be using an underscore or percentage. So, here we are using not underscore, we are just saying T followed by any substring. So, that is why we are using the percentage. So, select name class from student, where name like, we are using here like, here we are used where class equal to, here we are using like. So, you will get all the names of students who have name starting with T. Another example, list the red house members whose name contain A in the second as the second letter. So, select name class H code from student, where name like underscore, you want only one character to come before A. So, that is why underscore A and anything followed by it. So, this is it, and H code is equal to R. So, this is another example of the, so the result will be whose names. So, name, the second alphabet has to be A, that is the only condition we put. So, this is the operation. This is quite an expressive and important operation. So, next let us look at aggregate functions. These functions operate on multi-set of values. So, you have average, minimum, maximum, sum, count, these are some of the typical operations. So, it is a very powerful and it allows computations over sets of tuples, that is why it is called an aggregate operation. Count returns a count of tuples in the set. So, select count star from sailors S will give you the number of sailors in that, number of tuples in that particular relation. Average returns average column value. Select average S dot age from sailors S, where S dot rating equal to 10. This will give you the average age of all sailors whose rating is 10. So, min max returns min or max value, for example, and distinct can be added to count average sum to perform computation. Select average distinct S dot age from sailors S, where S rating is 10. You will take only sailors or you will take only as many tuples who have distinct ages. Okay. So, now let us take a tip example itself. Find name and age of oldest sailors. Okay. So, the age is this. So, find the name and age of the oldest sailors. So, select S dot name, maximum S dot age from sailors S. So, maximum here is 39. So, that we want to find the name and age of that. So, the answer, what will be the result? So, this result will be 39. So, here we have not shown, no, here the ages are 22 and 23. So, this 27 should not come. If Frodo and Sam had 39, you would have got this as the answer. So, this is not a legal sentence. No other columns are allowed in select clause without a group by. We will learn about these as we go along. Find name and age of, so actually you have to write it as select S dot S name S dot age from sailors S, where S dot age equal to select max S2 dot age from sailors S2. So, you have to define this separately and do this. So, this is the find the maximum age and then the sailors with that age. So, this is grouping. In many cases we want to apply aggregate function to subgroups of tuples in a relation. We do not want to apply it to everything. So, each subgroup of tuples consists of the set of tuples that have the same value for the grouping attributes. Please note that without grouping you would have got a wrong answer like this because of the fact that you are not using group by. So, here this is the correct answer which you have already seen. So, but for doing this in a more convenient way we have grouping. So, each subgroup of tuples consists of set of tuples that have the same value for the grouping attribute. So, this is where the grouping comes. So, the function is applied to each subgroup separately or independently, and so this is the group by clause which we will see. So, select from where condition group by group expression having requirement. So, group functions are count, sum, average, maximum, minimum. So, there you will use the group by. Group expression specify the related rows which you want or tuples which you want to group together as one entry, and usually it will be a column. So, where conditions specify the condition of the individual rows before the rows are grouped, and having requirement specifies the condition involving the whole group like age or whatever. So, list the number of, so let us look at this grouping example. List the number of students of each class. This is a typical example that you would want. So, like let us assume classes A, 1A, 1B, 1C. So, we want group by class. If you give, we want the answer, this is 1A, this is 1B, 1C. So, count, and then you want to group this, and then you want to count this. So, count. So, you will get, you want the answer to be, what is the answer? I mean the question is list the number of students of each class. So, actually I want the answer to be 3, 1, 2, 3, 6 and 3. So, that is what I want after this count operation. SQL query for this will be select class count star from student. Now, this is what we have brought newly, group by class. So, now when I group by class I will get this grouping, and then what I am doing? I am counting from that. So, the result I here is, suppose I had 1A group together, I have 10, 1B group, this will be the answer that I will get depending on. So, this select class group by class will group for me 1A classes together, 1B together, 1C together, students of 1C together, 2A together, 2B together and 2C together, and count star will count how many tuples are there in 1A and so on. Okay. So, list the average math score of each class. So, here instead of using count we are using average. Okay. So, this is the same, but only thing we will be using the average. So, list the average here, this is the only thing that changes, but group by class is the same. So, I will get class 1A what is the average math score, 1B what is the math score and so on. So, here instead of count which we had here we get, other than that we get the average math score. Here we are specifying count, we just put count star, count the number of tuples. Here it is slightly different, we are finding the average of a particular column attribute. List the number of girls of each district. Okay. Now, here the grouping is different. So, select decode, group by decode, decode gives me the district, and then count star from student. Here I am putting a condition, I want the sex field of that relation to be tuple to be equal to F. So, female I am taking care of female, I am grouping by district using this group, and then I am counting the number of students. So, I will get, this is the decode, and this will be the number of girl students that I am ensuring by putting this in each district. Another example, list the maximum minimum test score of form 1 students of each district. Now, here we are putting a little more complicated or interesting one. Select maximum M test, minimum M test. We are using two aggregate functions, decode, and we are giving the decode from student, okay, where class like 1 dash. So, 1A, 1B, 1C, it could be anything. So, here I am putting an underscore. This, remember, this says 1 character, group by decode. So, this part gives me maximum minimum, this is the test score, and then form 1 is indicated by this, and I am grouping it by district code by this. So, this is a operation of that. So, this will be my example, maximum, minimum and the decode. List the average math score of the boys in each class. The list should not contain class with less than 3 boys, I am putting additional. So, average M test, class from student. Here I am having count I am putting. So, I am putting an additional condition that the list should not contain less than 3. So, this is what will happen there. So, these are the find the average account at Perry branch, and these are type of example, number of tuples, number of depositors. These are examples that you can write with this type of operation, count and so on. Find the number of depositors of each branch, you can put distinct customer name, you do not want the same customer from depositor dot comma account, where depositor account number equal to account dot account number, and you want it by branch name for each branch. So, attributes in the select class outside of aggregate functions must be grouped by the list. So, find the names of all branches where the average account balance is more than, this is the use of the having average which we have already seen before, and having clause are applied after the formation of the groups, whereas predicates in the where clause are applied before forming the groups. So, this example, this is applied before forming the group, while this is applied after forming the group. Okay. So, this is the having balance. So far we have seen aggregation operations applied to all tuples. So, if you want to apply it to find the average age of the youngest sailor for each rating level, this also we can do. So, basically all this is possible. So, this we have explained set operation, we have explained comparison operation, and we have explained the very important grouping and aggregation, because this actually gives you the result. So, this is what we have done in this lecture. So, now let us look at some exercise. What do you think is the purpose of group by, order by? Order by we will be seeing, and having clause in the select statement, and when is actually the group by and having clause declared, and when is, how is it implemented. Let us try to find out some uses of the sum, average and count in a typical application. Take a typical application and show how this would be useful for. Thank you.